Wow, that's some beautiful drone footage. I like using that drone footage because we are a show based on what's in the atmosphere. So flying that drone puts us up there in the atmosphere and gets us above that tree line where we can see what's happening in the clouds. And here we have some cumulus and stratocumulus, and in the breaks in that cloud layer, we can see evidence of an inversion up there. Let's check that out on the high resolution rapid refresh and see what the sounding shows. There you go. This corresponds to what we saw on that drone flight. Got some steep lapse rates in the lowest 6,000 or 7,000 feet, and there's that inversion. And that's where we're getting that stratocumulus spreading out. I think there's some evidence of differential advection contributing to that inversion. See those northeast winds there? That's probably bringing in a slightly different air mass at that level. And that's about 7,000 to 9,000 feet, and the bulk of it, around 9,000 to 10,000 feet. So that's going to form a capping inversion, a pretty high-based one, but still a cap. And if we had a little more instability, that would suppress thunderstorms at that level. So the free atmosphere up in here and the boundary layer right down there. Yeah, I always think it's great when we can visualize stuff like that. Take what's out the window and see it on the products. So we'll give you an abbreviated version of what we saw yesterday. There's our main polar front jet way up there in the northern U.S. It looks like maybe a split flow. This might be a subtropical jet down to the south. One clue we can look at to see if this is a split flow or subtropical polar front jet, we can go to 500 millibars and see if we get rid of that pattern. And yeah, we do. So that's subtropical jet action down there and one main polar front jet up to the north. And abbreviated frontal system high pressure placement is going to look like this. It's a mess, but polar high right there over, looks like maybe Virginia and Pennsylvania, also far off the Pacific coast. And then our frontal systems are inland, surprisingly similar to yesterday. Looks like a baroclinic system up there in Wyoming with a trailing cold front down to maybe Vegas and Los Angeles, warm front on the central plains, and our outgoing baroclinic system well offshore there south of Newfoundland. And looks like the pattern is moderating. We're chipping away at the strength of that Hudson Bay vortex up there, and we're returning to more of a seasonal late spring pattern. A very important question this time of year is, how's the cap doing? And do we have any mesoscale circulations aloft? Yeah, we do have a mesoscale circulation. See this discontinuity in the wind field. There's something going on there. And this is maybe painting out maybe a trough right in this area and maybe a small scale ridge. That's probably associated with that outgoing MCS there that we saw in East Texas, Southeast Texas last night. And yeah, a thermal ridge, that's going to be right in this area here where we have the yellowest colors. That corresponds to about 10 Celsius, which is getting up towards a strong cap, and we did see evidence of that on the sounding earlier. One thing that's a good idea to do is drop a forecast sounding right in the middle of that thermal ridge. That'll give you an idea of the vertical extent and the character of that cap. Looks like it's kind of broad through a great extent, about maybe 800 through 600 millibars, centered at about 750. So that's good information to keep in mind. You can use that as you look at other soundings and kind of correlate that. Also, you saw the wind field back there. Yeah, very little shear. Let's go a little to the north, go into northwestern Oklahoma, where we also have the strong ridge. And what's interesting is, yeah, the temperature is about the same. It's 700, but quite warm at about 750 to 800. So the cap is a little more prominent there on the forecast soundings. in northwest Oklahoma. And we get more of a loaded gun sounding right there. But you can see the algorithmic hazard type is none. And I can see the reason for that is an almost nuclear cap there. See that convective inhibition? It's up from, depending on which parcel method you use, it's anywhere from 125 up to 200. But shear-wise, if we were to break that cap, and we can see that there is enough shear if we were to break that cap, some modest potential there for rotating storms. One problem, though, is the LFC. See how high that is? That's way up above 10,000 feet. That's the level of free convection, and that's the base of your cape layer. And typically on tornado days, we like to see that LFC a lot lower than this, because your strongest parcel accelerations are going to be in that layer there. So this is indicating your stretching is going to be concentrated in the mid-levels of the storm. Here's the surface analysis this afternoon there. We've got a Pacific front moving across the central Rockies. We can see the cool air flowing in from Nevada and Utah. We had gusty winds there overnight in places like Tonopah and Elko. The warm front that was in Texas yesterday has lifted into Oklahoma and western Kansas. That's brought the triple point north to about Shamrock, and that extends down the Caprock to Sanderson. Likewise, the maritime tropical air is flowing north through eastern Texas, and that's bringing up the stratocumulus from the Gulf. So we can see at first glance probably some of the best storm potential in western Oklahoma, maybe up the warm front into southwest Kansas, and maybe along the dry line. That's assuming that the atmosphere is cooperating for convective development. And out in the eastern U.S., we can see that cold polar high there moving off to the east. Very cold air in New England, 40s and 50s. That's been the story of the past month or so, just persistent cold weather. But on the west side of that high, large area of warm air advection bringing up moisture and, of course, warm air through the Mississippi River Valley. And you can see that vast area of isentropic lift from Missouri up to Kansas and Nebraska with low IFR ceilings, rain, and fog. So naturally, our attention shifts back to the Great Plains, and now we can start slicing and dicing the atmosphere in detail. Very warm conditions in the Oklahoma Panhandle down to Pampa, Dalhart, lots of 80s and 90s. We can see out to the east there, very cold temperatures, 50s and 60s, east of that warm front. So now that we're zoomed in a little tighter, we can check out that warm front placement, and that actually looks pretty good there. And I can see that the northwestern corner of the moist sector is out over Gould and Altus, Oklahoma. And that does place the dry line triple point right there around Shamrock. Pretty gusty winds back out there in the dry line air. You can see 35 knots there at Tucumcari, and that's about the strongest that I see there. Now, I suppose you could make a case for placing the front through here, although I fear that's getting a little bit too far north of the true boundary. This could be a change in the slope of the air mass. Maybe we go from very shallow air to very dense, deep air north of Stillwater and Medicine Lodge. And we'll look at what the HRRR is going for as far as the evolution of this air mass. So, yeah, going with our boundaries, I did go a little bit far south with that warm front. Dry line right there, and then tail another warm front up like that. So just a pattern of moist air advection, and as the afternoon goes on, It surges north into southern Kansas, and then by evening we find a little wedge of moist air around Pratt and Dodge City. So looks like maybe the dry line does not advance very far east, stays on those western tier counties of Oklahoma. And the other question is, how much convergence do we have? Let's look at those wind barbs. And what we see here is not very much convergence down along the southern part of the dry line. Yeah, maybe about, I guess I would call that modest, maybe 30 to 40 degrees of convergence, but much stronger there in southwest Kansas. So it looks like we have pressure falls out there around Springfield, Colorado, really backing those winds. So your best potential for rotating storms is going to be up in this area, and then that kind of trails off as you go south due to the limited shear. I can see already a very noisy pattern there, so I guess we're breaking out numerous cells this evening. Let me look at a forecast sounding there in southwest Kansas. Looks like it's pretty capped. Really wish we had a 775 millibar chart to look at. That would be pretty useful. And let's see how the model breaks out convection, focusing on I-40 southward. Cluster coming together and marching eastward to Oklahoma City and Wichita Falls around midnight. Okay, so it's got a very strongly diurnal signal there. And what we see also is numerous cells along that line. The capping is not too much of an issue. Let's look at our soundings ahead of these storms. We'll look at the Elk City, Oklahoma area. Yeah, it looks relatively uncapped there. So that's going to mean numerous cells and pretty decent shear there. And that's due to the winds running from about south-southeast, quickly switching around to southwesterly at 30 to 40 knots, 1 to 2 kilometers off the surface. So that stretches out the 0 through 2 kilometer shear line and really widens out this area of SRH. So yeah, the difference between south-southeast winds at 15 at the surface and southwest winds at 40 at 2 kilometers, that's what's really helping the shear profiles here. So even though we're getting numerous cells, now let's see here. Let's drop a sounding around the Childress area. Well, moisture problems. We go from 60 to 50s and 40s off the surface, and very limited capping, so we're going to have numerous cells. There's some limited potential there for rotating storms. And with that limited moisture and hot temperatures, look at that LCL way up there, almost at 8 or 9,000 feet. 2,500 foot LCLs, that's not going to be good for tornado genesis. Yeah, we're about right here, and this is where we need to be for tornadoes, kind of in that area. So not looking that great, but at least you will see storms. So yeah, this points to maybe somewhat high base storms. And I guess we're going to get a lot of cell collisions and cells being undercut by outflow. Let me go further down towards the Guthrie area. Moisture problems. So yeah, I think what we need is another day of moisture return. But, you know, if you're out there in Childress or Shamrock, I'm sure you'll see something at least. And it is May, so, you know, you can get surprises for sure. And checking in on the storm environment, we've already got elevated Q back there behind the dry line. So that's a good indicator of the approach of ascent and destabilization. And that'll probably work over towards the dry line. So I think we got pretty high confidence for initiation in a few hours, maybe in that area right there. So I think the high resolution rapid refresh is right on there. And as we saw in the forecast soundings, I guess the capping is more of an issue as you go north. And I wouldn't completely rule it out, though. I mean, that's pretty decent there. I think southwest Kansas could squeak out a cell there, and you can see that really good shear. So I guess if you were going to play a underdog area, yeah, I had to look at a map here because I've forgotten some of the towns. I guess south of Coldwater to Meade, maybe some potential in there. But I would imagine that would be a late show if anything like that comes together. So I'll be looking at an outside possibility of that, even though the models are not pointing to that at the moment. And then we look at SPC. Enhanced area, pretty much right ahead of that cluster of storms we're expecting later on. Got a mesoscale discussion up and a severe watch. And the key points here: multiple areas of convective initiation, and bulk shear is rather marginal, so that's going to help with outflow dominance and give us shorter lived storms and a little less organization. Large hail damaging gusts, and no mention of tornadoes. Yeah, so this goes back to the LCLs and limited moisture, low RH as being a big problem. So yeah, SPC going a little bit further north with that boundary. The cold front is always defined by a thermal boundary, not wind shifts or anything like that. And I can see we go from 85 to 70. That's a 15-degree difference. We even got 69 there in Oklahoma City. So I'm going to put that boundary down south. But I'm going to carry both of them and keep an eye on each one. It's possible that this may all mix out and become very strongly heated, and that could transfer to the main boundary up north. But for right now, yeah, look at those blustery conditions out there. 47 miles an hour north of Guyman and 48 at Boise City. Yeah, that's a bit of a blast furnace there. Okay, let's get this video uploaded so you guys have something to look at. Kind of happy we'll get that video out early so y'all can make use of that. Okay, have a great evening. Remember, if you like the webcast, support us either through Patreon or by grabbing a book from weathergraphics.com, and I'll pop that link up there for our website. Okay, have a good one, and we'll see you tomorrow. Bye-bye.